Next is diode as a full wave rectifier. In full wave rectifier, we will require a minimum of two diodes and the circuit is given here. So again, this is your step down transformer, so which will reduce the input voltage. Okay. Then there will be two diodes here, and between these two diodes, uh, our resistance will be converted here, and like this is the windings of the coil. So from here, this resistance will be connected here. So this is known as center tap because it is attached at the center of the step down transformer here, or you can say, sorry, secondary windings of step down transformer. This is your primary winding, this is your secondary winding of step down transformers. So as you can see from the diagram, this resistance is connected to the center of secondary winding, hence it is known as center tap. Okay, so this is our circuit diagram. Next will be our working. So let me again draw the diagram here. So we have connected a diode here, another diode we have connected here, and in between we have connected a resistance, and it's connected to the center of the secondary winding. Okay, 1 second. Yeah. Now let's go to the working of this full wave rectifier. So in the first half of applied AC input cycle, so in the first half, we can say that, let's say current is trying to move in clockwise direction. So current is trying to move in clockwise direction like this. So as this diode, this will be in forward bias. It will allow the current to pass, means current will be moving across this diode. So it will go like this, and it will also move along the resistance. But when current is moving, trying to move in this direction like this, as you can see, this diode is in reverse bias. To remember this, one easy method is, if diode is like this, you can see this is a sort of arrow mark. So we can say that it allows the current to move only in this direction, in the direction of arrow mark. So in this case, this will be in reverse bias. It won't allow the current to pass through it. So only this much current will pass through it, and the output will be like this. So as you can see, this was your input voltage or input current here. This will be output current or output voltage. So if you have kept a load here, or let's say you have kept a battery here, so that battery will start getting charged. Next is your second half of the applied AC input cycle. In second half, the potential difference or output voltage will change its direction, or you can say current will try to move in opposite direction. So let's say now in the second half of the cycle, like from here to here, current is trying to move in this direction. So like this, it will try to go like this. Now, when it is in this loop, you can see here, this diode, this is in forward bias. So it will allow the current to pass. So current will start flowing through this diode and it will go like this. Okay. When this current tries to move from this diode, it's in reverse bias. So it won't allow any current to flow through it. So there will be no current in this wire, but all the current will pass through this resistance. Hence again, we will get an output. So initially when it was in forward bias, the current was in the same direction. No? Here also, in the second half of the cycle, the current is also in the same direction. So you can say this will be your output. Next, again, this whole cycle will get repeated again, and hence you will get this output. So this will be your DC voltage output. Same will be your current output. So this is your working of full wave rectifier. Now the difference between half wave and full wave rectifier is, see, in half wave rectifier, From here to here, there was no current passing through our resistance, or in place of resistance, if we have kept a battery, there was no current passing through that battery, means that battery won't get charged during this period. But in full wave rectifier, as you can see, there is always currents passing through that resistance. So if we have kept a battery there, that battery will get charged automatically. Always it will get charged. So this is your working of full wave rectifier. Thank you.